Hi, in this video, let me explain you about implicit differentiation. So, what is an implicit function? Implicit differentiation. What is an implicit function? So far, we have been dealing with the functions which are of the form y is equal to f of x. What I meant by y is equal to f of x, like y is equal to x square, y is equal to sin x, y is equal to e power x, y is equal to sin inverse of x, and so on. So, and even it is, we have learned the differentiation of those functions. For example, take an equation x minus y minus 5 is equal to 0. If I can simplify it further, I can express the same equation as y is equal to x minus 5. I am able to express the function y in terms of x explicitly, so it is an explicit function. For example, take a function y minus sin of xy is equal to 0. Now, can you express this function y explicitly in terms of f of x? Let us try. Y minus sin of xy is equal to sin of xy. So then sin inverse of y is equal to xy. Whatever I might do, I could not express y in terms of x explicitly. So this is an implicit function. In this video, let me explain you how to solve the differentiation of the implicit functions. What I suggest you is, I'll give you 3 steps. Follow the 3 steps carefully so that you can understand what exactly I meant to say. So in step 1, find the derivative of the entire function with respect to x. Let me explain the steps first, then I'll solve 1-2 examples, then I'll solve around 10 to 15 questions so that you get very good clear idea about implicit differentiation. First step is find the derivative of entire function with respect to x. Find the derivative of entire function. Find the derivative of entire function with respect to x. This is the first. So if you are given any function, it is implicit function, don't worry, just do the derivative of entire function with respect to x. It is with respect to x. In step 2, you need to solve for dy by dx. Solve for dy by dx. In step 3, if a specific solution is asked, substitute the corresponding values of x and y. Specific solution is asked. What is specific solution is, find dy by dx of y minus sin of xy is equal to 0 at x is equal to 1 and y is equal to 2. Means they are particular about the values of x and y. If the specific solution is asked, what you should do? Substitute the values of x and y. Substitute the values of x and y. So let me repeat the steps. An implicit function is a function which cannot be expressed explicitly y in terms of x. And what is the process to do differentiation of implicit differentiation? First, find the derivative of entire function with respect to x. Then the second step should be solve for dy by dx. And third step, if at all required, find the specific solution by substituting the values of x and y. Let me solve 1 or 2 examples so that you get an idea. Then I will give you some good amount of questions for practice. Find the derivative of x square plus y square is equal to 16. Yeah, y is equal to, I can express it as implicit function, explicit function, but not required. So just do the steps as mentioned earlier. Differentiate the given function with respect to x. So d by dx of x square plus y square is equal to d by dx of 16. D by dx of x square, I can write this as d by dx of x square plus d by dx of y square. D by dx of 16 is 0. Derivative of x square is 2x and derivative of y square is 2y into derivative of y is dy by dx is equal to 0. So 2y into dy by dx is equal to minus 2x. The 2 and 2 get cancels. So dy by dx, derivative of the given function is minus y upon x. Hope you are clear. I am doing the same steps. Here they are not asking for specific solution, so I not required to do step 3. So first differentiate the entire function. Step 1, as I said in the earlier video, differentiate the entire function with respect to x. I am differentiating. Once I differentiate, the second step, solve for dy by dx. I am solving it for dy by dx. Now the same question, find the derivative of the function x square plus y square is equal to 16 when x is equal to 2. So x square derivative is 2x, y square derivative is 2y into dy by dx. 16 derivative is 0. So if I simplify this, which I have gotten earlier page, dy by dx is minus y upon x, y minus x upon y. So if x is equal to 2, what is the value of y? 2 square plus y square is 16, y square is 12, means y is plus r minus 2 root 3. So dy by dx is minus 2 by plus r minus 2 root 3. So you get minus r plus 1 upon root 3. So you get two values when x is equal to 2. This is what they meant to say, that find the derivative of the given function, implicit function, at x is equal to 2. Let me solve another example. Find dy by dx if y plus sin y is equal to cos x. So again, first step would be differentiating both sides with respect to x. So derivative of y plus sin y is equal to derivative of cos x with respect to x. So this would be dy by dx plus derivative of sin y would be cos y into dy by dx, and derivative of cos x is minus sin x. Take dy by dx common. If I take dy by dx common, I am left with 1 plus cos y. 1 plus cos y is equal to minus sin x. So dy by dx is therefore minus sin x upon 1 plus cos y. This is the value for dy by dx. Now let me solve some around 10 to 15 questions in implicit differentiation, so that you get very good clear idea about implicit differentiation functions. Let me solve from easy, medium to difficult questions. Find the derivative, first question, find the derivative of 2x plus 3y is equal to sin x. So the first step would be differentiating both sides with respect to x. So d by dx of 2x plus 3y is equal to d by dx of sin x. So if I expand d by dx of 2x plus d by dx of 3y is equal to derivative of sin x we know is cos x. Derivative of 2x is 2 plus derivative of 3y is 3 times dy by dx is equal to cos x. So 3 times dy by dx is cos x minus 2. So dy by dx is cos x minus 2 upon 3. Cos x minus 2 upon 3. Very good. Second example. Find the derivative of 2x plus 3y is equal to sin y. So the same thing, differentiating on both sides. So if I do differentiation on both sides, I'll get d by dx of 2x plus d by dx of 3y is equal to derivative of sin y with respect to x. So derivative of 2x is 2 plus derivative of 3y is 3 times dy by dx plus derivative of sin y is cos y into dy by dx. So 2 is equal to cos y minus 3 into dy by dx. It implies dy by dx is equal to 2 by cos y minus 3. Very simple, right? Yeah, if you follow the steps, it's very simple and very clear too. Just differentiating it on both sides, you get the answer. I hope you are clear. If not, you can come back at any time and look at the solution. Let me solve the next question. Find that if ax plus by square is equal to cos y, find the derivative of this function. So derivative of this function is d by dx of ax plus by square is equal to d by dx of cos y. So I get it as d by dx of ax plus d by dx of by square, derivative of cos y is minus sin y into dy by dx. A times derivative of x plus b times derivative of y square is equal to minus sin y into dy by dx. Solve all these problems for practice so that definitely you are 100% clear, will be clear with implicit differentiation. So a times derivative of x is 1 plus b into derivative of y square with respect to x is 2y into dy by dx is equal to minus sin y into dy by dx. Let me take dy by dx to one side and constants to the other side. So if I simplify, I get dy by dx. Let me bring everything one side. Sin y plus 2by is equal to minus a. It implies dy by dx is equal to minus of a by sin y plus 2by. This should be the answer. Hope you are clear. You can have a glance at this for a second. I'm just doing nothing. Just follow my steps. First step should be differentiate the entire function with respect to x, then solve for dy by dx. Only in one question I have asked you for specific solution. Another question they are just asking us to find dy by dx. So we are just finding dy by dx. If they ask us to find specific solution, very simple. In this result, which we have got the final result, just substitute the values they have given. Here I do not have any x, so just find the value of y, or if they give any value of y, just substitute, and that would be the specific solution. Let me solve another example. Take a function xy plus y square is equal to tan x plus y. So differentiating with respect to x on both sides, differentiation d by dx of xy plus d by dx of y square is equal to d by dx of tan x plus d by dx of y. dy by dx. What is the derivative of xy with respect to x? X into dy by dx plus y into derivative of x with respect to x plus derivative of y square with respect to y is 2y into dy by dx. Derivative of tan x is secant square x plus dy by dx. So let me take all dy by dx to one side, that is x into dy by dx plus 2y into dy by dx minus dy by dx is equal to secant square x minus y. So if I take dy by dx common, it becomes dy by dx x plus 2y minus 1 is equal to secant square x minus y. It implies dy by dx is equal to secant square x minus y upon x plus 2y minus 1. So don't get afraid by looking at the function, just follow the steps and see how it is easy to find the differentiation. Good, hope you are very clear. Let me solve the next question, that is x square plus xy plus y square is equal to 100. How to find differentiation of this function is find the derivative of this function on both sides. Derivative of x square plus xy plus y square is equal to the derivative of 100 with respect to x. 100 is a constant, so this derivative will be 0. So what is the derivative of x square? Derivative of x square plus derivative of xy plus derivative of y square is equal to 0. It implies derivative of x square is 2x plus derivative of x would be x into dy by dx plus y into dx by dx, derivative of x with respect to x, plus 2y into dy by dx is equal to 0. It implies 2x plus x into dy by dx plus y into derivative of x with respect to x will be 1 plus 2y into dy by dx is equal to 0. It implies 2x plus y plus x plus 2y into dy by dx is equal to 0. Therefore, dy by dx is minus of 2x plus y upon x plus 2y. Okay, hope you are clear with this. Let me solve next question. Find derivative of x cube plus x square y plus xy square plus y cube is equal to 81. Okay, do differentiation on both sides, that is derivative of x cube plus derivative of x square y plus derivative of xy square plus derivative of y cube is equal to derivative of 81 with respect to x. So this would become 3x square plus x square into dy by dx plus y into derivative of x square plus derivative of xy square would be derivative of x into derivative of y square with respect to x plus y square into derivative of x with respect to x plus derivative of y cube would be 3y square into 3y by dx. Derivative of constant, which is 81, is 0. So 3x square plus x square into dy by dx plus y times x square plus x times derivative of y square would be 2y into dy by dx plus y square plus 3y square into dy by dx is equal to 0. So 3x square plus x square y plus y square plus dy by dx x square plus 2xy plus 3y square is equal to 0. I am just separating the terms. Therefore, dy by dx would be minus of is equal to minus of x square plus 2xy plus I just need to write here reverse terms. Dy by dx is minus of 3x square plus x square y plus y square upon x square plus 2xy plus 3y square. Hope you are there. Sorry, this step. So far I have solved around 9 questions including examples. It's not so difficult. Whatever might be the function, just don't worry about the function. Just start differentiating both sides with respect to x. That should be your first step. Let me increase the difficulty level, easy to medium. Find the derivative of the function sin square y plus cos xy is equal to k. Again, differentiating both sides with respect to x, derivative of sin square y with respect to x plus derivative of cos xy with respect to x plus derivative of constant with respect to x. So derivative of sin square y is 2 sin y into derivative of sin y with respect to x plus derivative of cos xy would be derivative of cos is minus sin, it would be minus sin xy into derivative of xy into derivative of constant is 0. So 2 times sin y into derivative of sin y would be cos y into derivative of y is dy by dx. This is minus sin xy into derivative of xy is x into derivative of y with respect to x plus y into derivative of x with respect to x is 1 is equal to 0. So if I simplify this, I get 2 sin y cos y. 2 sin y cos y can be written as sin 2y, which you have learnt in trigonometry classes, minus x times sin xy into dy by dx minus y times sin xy is equal to 0. So this can be written as sin 2y minus x into sin xy into dy by dx is equal to y times sin of xy. Therefore, dy by dx is simple y sin xy upon sin 2y minus x sin xy. Sorry, you can just go through this for a second. Did nothing. Follow the steps. Differentiate both sides with respect to x. Once you differentiate both sides with respect to x, then solve for y. Follow my steps clearly. You will not face any difficulty in understanding the questions. And you need to solve all these questions on your own. Once you start solving these questions on your own, you feel more and more comfortable. Okay? Let me solve the next question then. Find the derivative of the function sin square x plus, it is not cos square x, it is cos square y is equal to 1. So differentiating both sides with respect to x, derivative of sin square x plus derivative of cos square y with respect to x, again derivative of cos square y with respect to x is equal to derivative of 1 is 0. So derivative of x with respect to sin square x is 2 sin x into derivative of sin x plus derivative of cos square y is 2 cos y into derivative of cos y with respect to x is equal to 0. 2 times sin x into derivative of sin x is cos x plus 2 cos y into derivative of cos y is minus sin y into dy by derivative of y would be dy by dx is equal to 0. So this can be written as dy by dx is equal to minus 2 sin x cos x upon minus 2 sin y cos y. The negative in the bottom and the top gets cancels. So 2 sin x cos x, I can write it as sin 2x. 2 sin y cos y, we can simplify it as sin 2y. So the answer is sin 2x by sin 2y. Good. We can go to this for a second. Then I will go to the next page. Let me solve some 7 more questions. Bit difficult questions, but they are not. Once you practice them, nothing is difficult. Follow the basics. Maths is so easy because I am able to solve so many pages by not remembering anything. Just few basic formulas. That is the wonderfulness of maths. Just know the basics properly, apply them. You will be the master. You will be the master. When you start application of this, which is application of differentiation, then I'll tell you how you can relate the differentiations which you are doing to the real life situations. Let me start with application of differentiations later chapters. Then definitely you will be in a better position to understand why we are doing these differentiations of so many functions. Okay, now let me solve the next function, that is y is equal to sine inverse of 2x by 1 plus x square. So I can do dy by dx is equal to, what is the sine inverse of x derivative? 1 by root of 1 minus x square. Instead of x I have here 2x by 1 plus x square. I can replace x with 2x by 1 plus x square and again do derivative of 2x by 1 plus x square, blah blah so on, which according to me is a waste of time. So in trigonometry I have learned some formula. What is that formula? Is 2 tan theta by 1 plus tan square theta is sine 2 theta. My mind strikes, yes. Why can't I replace x with tan theta so that this becomes sine 2 theta? So that sine inverse and sine gets out and I am left with just 2 theta. So let me take x as tan theta. If I take x is tan theta, what is the value of theta? Theta is tan inverse of x. Good. So y is sine inverse of 2 tan theta by 1 plus tan square theta. Two tan theta by 1 plus tan square theta is sine 2 theta, that is sine inverse of sine 2 theta. Sine inverse of sine 2 theta is 2 theta. 2 theta is 2 tan inverse of x. See, so complicated function sine inverse of 2x by 1 plus x square has been simplified. This function is same as 2 tan inverse of x. So now differentiate both sides with respect to x. Therefore dy by dx is derivative of 2 tan inverse of x with respect to x, 2 times tan inverse of x, take 2 to the 2 comes out. So derivative of tan inverse of x. What is the derivative of tan inverse of x? 1 by 1 plus x square. So answer would be 2 by 1 plus x square. If not, we can do the same thing. Sin inverse of x is 1 by root of 1 minus 2x by 1 plus x whole square into derivative of 2x by 1 plus x whole square. You need to simplify this, you get the same thing. We need to be smart enough. If you are smart enough, you can solve this question very easily when compared to others. You can go through this step by step. Any issues, please let me know. Okay, let me solve the next question. Next question is, find the derivative of the function y is equal to tan inverse 3x minus x cube upon 1 minus 3 times x square. Let x is equal to tan theta. So you get y is equal to tan inverse of 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So your mind strikes, this is the formula for tan 3 theta. So that is tan inverse of tan 3 theta. This becomes 3 theta. It implies theta is tan inverse of x. So this would become 3 tan inverse of x. Y is 3 tan inverse of x. Therefore, dy by dx is 3 times derivative of tan inverse of x. That would be 3 by 1 plus x square. Excellent. Okay. The question looks so terrible. Y is tan inverse of, you can do the same thing, 1 by 1 plus x square. Instead of x you can replace with 3x minus x cube by 1 minus 3x square whole square into again derivative of this function, which is 3x minus x cube by 1 minus 3x square. Doing this might be cumbersome. So the smart way to solve this problem is, immediately when you see 3x minus x cube by 1 minus 3x square, from trigonometry you should identify that yes, this is the formula for 3 tan theta, tan 3 theta when I replace x with tan theta. So if you can get that idea into mind, this problem is nothing, very simple. If not, it's very difficult. You might make many careless mistakes if you do direct steps. And I would like to state that what would be the domain of this function? The domain of this function should be, x should lie between, even since it is in the denominator, even it cannot be equal to, this is just the question. This will be stated in the question because this is the domain of the function. Next question. Find the derivative of the function y is equal to cos inverse 1 minus x square upon 1 plus x square for 0 less than x less than nothing. This is the condition domain of this function. So again the same thing, replace x with tan theta. If you replace x with tan theta, theta becomes tan inverse of x. So y is equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. So we know this is the formula for cos 2 theta. So this becomes cos inverse of cos 2 theta. Cos inverse and cos gets cancelled, so we get 2 theta, that is same as 2 times tan inverse of x. So dy by dx would be 2 times derivative of tan inverse of x. that would be 2 times derivative of tan inverse of x is 1 by 1 plus x square. That would be 2 by 1 plus x square. So simple. I think we have got hold of these types of questions which are most important, which many students struggle. Let me solve the next question. Find the derivative of the function y is equal to sine inverse of 1 minus x square upon 1 plus x square. What should be the domain of this function? For should between 0 less than x less than 1. Take x is equal to tan theta again. So y would become sine inverse of 1 minus tan square theta by 1 plus tan square theta. What is the formula for 1 minus tan square theta by 1 plus tan square theta, which is cos 2 theta? You might wonder, I have sine inverse here and y is solving for cos 2 theta. Immediately your mind should strike cos can be written as sine. Sine inverse of cos can be written as sine of pi by 2 minus 2 theta. Sine inverse and sine gets cancelled, so that is same as pi by 2 minus 2 theta is minus 2 times tan inverse of x. This is y. So dy by dx would be derivative of pi by 2 0 minus 2 times derivative of tan inverse of x is 1 by 1 plus x square. So this would be minus 2 upon 1 plus x square. You can go through the solution once again. I shall wait you for a few seconds, then we can solve 3 more questions. Then we are done. Stop. Good. Next question would be y is equal to cos inverse of 2x upon 1 plus x square for minus 1 less than x less than 1. Again replace x with tan theta. So y would be cos inverse of 2 tan theta upon 1 plus tan square theta. So which would be cos inverse of sine 2 theta. That would be cos inverse of sine 2 theta is cos of pi by 2 minus 2 theta, which would be pi by 2 minus 2 tan inverse of x. So dy by dx is 0 minus 2 by 1 plus x square, so that would give me minus 2 by 1 plus x square as answer. Okay, now you might feel maths is so easy. It is very easy, very easy, just the confidence makes the difference. Let me solve the function. Y is equal to sine inverse of 2x into root of 1 minus x square. Definitely the domain of this function should be 1 by root 2 less than x less than 1 by. Okay. Now if we replace x with tan theta, it does not make sense here. My mind should strike 2 sin theta into cos theta is sin 2 theta, and root of 1 minus sin square theta is cos theta. So definitely my mind says substitute x is equal to sin theta. So if I substitute x is equal to sin theta, y is equal to sin inverse 2 sin theta into root of 1 minus sin square theta. That is 2 sin theta, and 1 minus sin square theta is cos theta. Sin 2 sin theta cos theta is sin 2 theta, therefore sin inverse of sin 2 theta, which would give me 2 theta. So if x is sin theta, theta would be sin inverse of x. Theta is sin inverse of x. So this would be 2 times sin inverse of x, which would be 2 by root of 1 minus x square, which is derivative of y with respect to x. You can go through this, then I'll solve the last problem. If y is equal to secant inverse 1 upon 2x square minus 1 for 0 less than x less than 1 by root 2, find dy by dx. So I know 2 cos square theta minus 1 is cos 2 theta, 1 by cos is secant, secant inverse and secant square. So I shall replace x with cos theta. You get y is equal to secant inverse 1 by 2 cos square theta minus 1. That is equivalent to secant inverse 1 by cos 2 theta, that is equal to secant inverse of secant 2 theta. Secant inverse of secant would be 2 theta, that is equal to 2 cos inverse of x. So dy by dx would be derivative of 2 cos inverse of x, which would be minus 2 upon root of 1 minus x square. Oh, you are clear with this part. Just for your information, the questions after the examples which I have been solving are from 12th CBSE NCERT book. So you can just go through the book first and solve them. If you could not get them, then you can come back and check for solutions here. That would make more sense, right? I hope you have enjoyed watching this video. I shall see you in the next video. Have a good time till then. Bye.